Okay, let's finish this lesson with problems 7-52 and 53. You're going to do what you normally do by reading while pausing and then playing when you're ready to pick it back up. Note in letter A, you are going to need tracing paper. Now, if you don't have tracing paper, that's no problem. You can simply use your graph paper or any white paper and hold it up to the computer screen and do your best to trace that kite that they're mentioning. All right, so go ahead and read the intro in letter A and then hit play when you're ready to pick it back up. All right, in letter A, they told us to add the other diagonal, which means we're going to connect this vertex to this vertex to make the second diagonal. They then tell us to explore and conjecture what might be true about these two diagonals. So go ahead and take your drawing and fold it, analyze it, and see what you think is true about those diagonals. Hit pause and then play when you're ready. Okay, my two conjectures, not that I am a geometry teacher or anything, but I would conjecture that this segment is congruent to this segment. Looks pretty obvious. If you fold it over, they line up perfectly. So that's a good conjecture. Another one is those look to be 90-degree angles here, 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 and here. So that means that those two diagonals would be perpendicular. Now, we haven't proven either of those conjectures, but they're good conjectures. So one, the two segments are congruent, and two, the diagonals are perpendicular. Let's move on now to C, where we're going to try and prove that. Okay, hit pause, read through C, and then play when you're ready. So problem C asks you to make a flow chart. Here's one example that you could have made to prove that these two triangles here are congruent. Note that they are referring to these triangles here and enlarging them here. So here's one flow chart you could have made to prove that triangle ACD is congruent to triangle BCD. Notice there are a few question marks there. Pause the video, copy this down, and see if you can fill in the missing pieces. So as we look at this, you can see what's in blue on the left bubble. We're referring to what's given here, that this side and this side are congruent. The middle bubble in red, we're referring to what's given here, that this angle and this angle are congruent. So what else is true that we can add in this green bubble? Well, hopefully you looked at this side here, and we could say that side CD is congruent to side CD. Why were we able to say that? Well, it's the same side. If you wrote shared side where the question mark was down here, that's fine. You could say shared side, or we could call that the reflexive property. If you take a moment, pause the video, and scroll down to the math notes box for this lesson, you'll see more on the reflexive property. And then now, looking at our conditional statement with the if, our condition being all of this, if these three are true, then the arrows are the then. This is true. Why are we able to make that conclusion based on those three conditions? Well, hopefully you looked and you said, all right, well, we have two sides, two pairs of sides that are congruent, and then one pair of angles, and that pair of angles is the included pair of angles, meaning it is between the two pairs of sides we're using. And so that is the condition for side, angle, side congruence. All right, now that we've proven those two triangles are congruent, can we use that to try and prove our conjectures that we made up here? Well, in order to do that, we now need to take our conclusion here, and we're now going to make that our new condition, our new if. So if the triangles are congruent, which we just proved, then what else can we say is true? Think about the two conjectures we made, and can you quickly prove either one of those is true because the triangles are congruent? The answer is yes. We can prove that segment AD is congruent to segment BD. So segment AD is congruent to segment BD. Why are we allowed to say that? Well, since the triangles are congruent, which we proved above, that means that all of the corresponding parts are congruent. So we're just going to word it that way. We'll say it in a shortened way. Congruent triangles arrow, meaning then congruent parts. So this is a short way to say if triangles are congruent, then the corresponding parts are congruent. So we proved that part, but now what about this angle? Are those right angles? Well, we could extend the proof and add some extra bubbles. I'm not going to walk you through all of that, but I'm going to walk you through this quickly. We know that this equals 180. And we know that these two angles are congruent because the triangles are congruent. Well, if those are the same and they add up to 180, then what do they each have to be? That's right, 90 degrees. Okay, so we just proved our two conjectures are true. So let's go to our toolkit and let's add it. Okay, so here we have this. All right, let's add what we just discovered to our toolkit. Now I just realized that we didn't add the definition or the special properties we previously identified to the shape. So let's do that first. Now the definition, a quadrilateral with two pairs of consecutive equal sides, equal or congruent could be used. So consecutive meaning one right after the other. So there's one pair of consecutive congruent sides. There's another pair of consecutive congruent sides. There's the definition of a kite. Next, the properties, one pair of opposite angles is congruent. So we have this pair of opposite angles is congruent. Those two angles are congruent to each other. Then the other property, the other pair of opposite angles is bisected by the diagonal. So let's draw the diagonal. Connect this vertex to that vertex. And so if you remember, these angles are congruent, meaning that one big angle here was cut in half to create those two. And over on the other side, this one big angle was cut in half to create two congruent angles. Now, let's go ahead and draw the other diagonal and add our most recent conjectures that we just proved to be true. So the first one was this right here. Let's mark it on the shape and then we'll discuss how we can write that. So we identified that this segment is congruent to this segment. So how can we describe what just happened? Well, it means that this diagonal here was cut in half by the other longer diagonal. What's the word again for cut in half? That's right, bisect. So one diagonal is bisected by the other diagonal. And then lastly, we identified that those are right angles where they intersect. And so we can say diagonals are perpendicular to each other. That's it for the toolkit and the special properties of a kite. Now, the very last problem, problem 53, basically says to reflect on all the things you've identified with parallelograms and kites and to record them on your theorem toolkit. Well, instead of the theorem toolkit that's linked in the lesson, we have this special Chapter 7 toolkit, and we've already added the definitions and the special properties. So you know what that means. Now, the last problem of the lesson, 7-53, asks us to reflect on what we've identified with parallelograms and kites and to write them on this theorem toolkit linked in the lesson. Now, as you've seen, we have our own even better toolkit that we've been writing all this information on, so you've already done 7-53. Great job on this lesson. Make sure you check in with your teacher if they have Zoom calls or any time to go over questions and any problems you have with this lesson. All right, we'll see you next time.